All right, good morning, happy Monday. Now, we're going to be looking at section 10.6 today. So, for today's lesson, we'll be doing 10.6. We'll come back to 10.6 tomorrow as well. So, just a preview for the week. Monday, Tuesday, like I said, 10.6. Keep an eye out on Tuesday because you will have a 10.5 mini quiz on SchoolNet. And I'll kind of guide you through getting on that one. Wednesday and Thursday, we will review 10.4 to 10.6, and then Friday, we'll have a 10.4 to 10.6 kind of a quest or test, 10.4 to 10.6. So I'll be available all week to answer questions about that. So Friday will be a 10.4 to 10.6 quest. Now we're going to classify these types of segments that you see here. I'd like you to pause the video for just a second and try to classify these. So AB goes from one point on the circle to another. So that is a chord. AC is a line, goes through the circle. That is a secant. And DE only touches the circle one time. So that is a tangent. Now we've got two theorems for today. And they come from this theorem back here from our last chapter, chapter 9. And we were looking at AC divided by CE. Remember we drew in the very thick division bar equals AB over BD. And we're going to use a similar approach. This theorem here works in the same way. But you can see if I connect this line and this line, these are not parallel lines. I mean, if I kept going, these are going to intersect at some point down here. So the really confusing part is that these are going to have to be flipped, these last two sides, in my formula. And you really don't need to know that so much, but I just want to let you know where that came from. So what we're going to do is we're going to say EA divided by ED. I'm going to take this segment here and divide it by the full segment across from it. Now do the same thing. Let's say EC over EB. EC over EB. And if we cross multiply EA times EB, if we cross multiply EA times EB equals EC times ED. And that's just where it's coming from. I just wanted to introduce it that way. But let's look at what this means practically. What I'm going to be doing is I'm going to take the part outside the circle here, and I'll be multiplying that by the whole secant. So I've got 3 for the part outside. Now what's the whole secant here if I have 3 and 5? Well, 3 plus 5 gets me 8. So the left side here, this secant on the left, is going to be 3 times 8. And I'll set that equal to 4. And now what's the whole segment? 4 plus this other part x. So 24 equals, and if I distribute here, 16 plus 4x. And now I'll just solve for x. So 8 equals 4x. X is 2. So the important part again is we took the part outside the circle, times the whole segment. So 3 times 8 equals the part outside the circle times the whole segment. So let's try this over here. Well, what's the part outside the circle? 7. And what's the whole segment if I go all the way down? Well, 7 plus 9 is 16. 7 times the whole thing here is 16 equals, well, the part outside the circle is 8x. And now what is this whole segment here? What is 8x plus 6x? 8x plus 6x is 14x. So I've got, let's see, 112, 70 plus 42. So 112 equals 8x times 14x. And what is 8 times 14? Well, that's pretty lucky. That's also 112. X. And now we've got to really be careful. X times x is x squared. So if I divide the 112 from both sides to get x squared by itself, I get 1 equals x squared. And now what's the opposite of squaring a number? Well, I can square root to get rid of that. So x is 1. All right, why don't you guys try just setting up your first step, outside times the whole thing on these next two, and then unpause the video and let me know how it goes. So here we've got 4 on the outside times the whole thing. And the whole segment here is 4 plus 2 is 6. And that's going to be equal to 3 times 2x plus 5 plus 3. And we could simplify that. We could say 24 equals 3 times 2x plus 8. And let's try this last one here. So 3 on the outside times x minus 5 plus 3 equals 4 on the outside times the whole thing, which is x minus 8 plus 4. And let's simplify that. So 3 times x minus 2 equals 4 times x minus 4. And now what we would do is distribute. So 24 equals 6x plus 24. And 3x minus 6 equals 4x minus 16. So our last step, minus 24, 6x equals 0, so x equals 0. And if I subtract 3x, negative 6 equals x minus 16. So x equals 10. But what do I do when the whole segment is outside the circle? Well, I'll still do the same thing. X times x plus 5 equals, and 6 is outside the circle. But now, what's the whole segment here? Because we'd been doing the part outside times the whole segment. Well, that's not going to change. We'll do the part outside. But what's the whole segment here? So that's the whole segment. This is the whole segment still. 6 is just the whole segment now. So x squared plus 5x equals 36. And now what I'm going to do is I'm going to subtract 36 over here to say x squared plus 5x minus 36 equals 0. And now we will end up factoring this to solve for x. So let's just set up the next 3, just our first step. Part outside times the whole thing. So 4 times the whole thing is 4 plus x equals part outside the circle is 6. What's this whole segment here? Well, that's still 6. So 16 plus 4x equals 36. Alright, why don't you guys set up the last 2 for me? So pause the video and set up these last 2, and then we'll do some chords. So 9 times 9 plus x equals 15 times the part outside the circle times the whole segment. Outside, whole segment, they just happen to be the same thing here. And part outside is 12 times the whole segment is 27 equals x plus 8. But what's the whole segment here? That's the part outside. What's the whole segment? Well, that's still x plus 8. And now how would I solve this last one here? I think it's important to go over that. So 12 times 27. would get me 324 equals, and if I FOIL this first, plus the outers, 8x, inners is 8x, 8x plus 8x is 16x plus 64. Now I'll subtract, I should do that in another color. I'll subtract 324 from both sides. So x squared plus 16x minus 260. And we will end up factoring that to solve for x. So we've got to find our factored form there. All right, and our final theorem, this one's even nicer. If I've got two chords, what I'm going to do is I'm going to take one part of the chord and just multiply it by the other part. I don't have to add anything here. So I could say x times 4 equals 5 times 8. So 4x equals 40. Or x equals 10. Same thing here. I'll just take one part of the chord times the other part of that same chord. Don't need to add anything. So 4x times 9, I'll set that equal to 4x plus 2 times 8. But the thing we've really got to be careful about here is distributing. So 36x equals 32x plus 16. And if we subtract 32x, 4x is 16 and x is 4. So using the same approach, I want you guys to solve. You know what, I want you to just set up these first steps in the last two. So just do your first step here. So part times the other part. So pause the video and try that one, and then unpause and see how it went. So 12 times 2x plus 5 equals 14 times 2x plus 2. And here, 12 times 4x plus 1 equals 14 times 3x plus 3. And then, of course, we could distribute and distribute to solve for x. But I'm going to leave that up to you, and